We're now going to turn our attention to the final set of Java completable future methods, the so-called arbitrary-arity methods. And we use arbitrary-arity methods to process completable future objects in bulk or en masse. So let's talk a bit about that. So if you recall our discussion of completion stage methods, there were different categories of them. Some could be completed only when a previous stage completed. Some would be completed after two previous stages both completed. Some would be completed after either of two previous stages completed. But the bottom line is it was either one or two things that you could be triggered by if you're a classic completion stage method. And the problem, of course, there is that that's not sufficient in some cases. We sometimes want to be able to trigger completion stage methods or a completion stage method after an arbitrary number of futures complete, not just one or two. And we have a good example here that we've talked about a number of times. This is from the EX8 project in my Java 8 folder in my live lessons repository on GitHub, where we needed to convert a stream of completable future objects that were all being reduced and multiplied asynchronously into a single completable future that we could then use to get the final results and print them when we're all done. So that is not going to work if we only have two. It needs n. So to support that, there are these things called arbitrary-arity methods. And they're not quite the same as the other completion stage methods. They don't really fit into the flow in quite the same way. And we'll talk about them. They're more static methods as opposed to completion stage methods. And the way that they work is that they take in an array of completable futures, and they return a single completable future that will be triggered when either any of the other completable futures are done or all of the other completable futures are done. And that's where the word arity comes from. Arity just means the number of parameters you can pass to a method. So arbitrary-arity means you can pass any number to them. There are two arbitrary-arity methods. One of them is called allOf, and allOf takes a variable length argument parameter, so it could be an arbitrary number. It returns a completable future to void, which, as we'll see, is a little wacky. And it gives us back one completable future that completes when all the completable futures passed as the varargs parameter have completed. The second example is anyOf, and anyOf takes the same parameter, a variable length argument. It returns a completable future to void, and that completable future will trigger when the first or any of the completable futures in the parameters complete. So allOf, anyOf. Pretty straightforward concept, quite frankly. Now, what you get back is this completable future, and you can use it to wait, and I'm using the word wait in quotes, for any or all of the futures to complete. And it turns out that what you typically do there is you typically don't wait. You typically do something else. So you don't block. Instead, you're going to be using a completion stage method, like then apply or whatever, to process the results reactively as all the other things complete. So it's this really cool feature. It's very much like the wait for multiple objects method that's available in Windows and the Windows API. It's a little bit kind of like the select or poll methods that are in the Unix or POSIX API. Not quite as much like that, more like wait for multiple objects. And it's a really, really powerful mechanism to make it possible to program things that have to wait for lots of stuff to finish. The benefit of this, if you map it back to the reactive programming model we've talked about before, is it makes the programs more responsive by not blocking caller code. So that's almost always a theme, almost always a principle in reactive programming, is trying to avoid blocking. So by doing this, we don't have to block, but lots of things can run, and we can get notified when all the computations are finished. In our analysis here, we're going to be focusing on the allOf method, which is a bit like then combine on steroids. So if you recall, then combine would combine two things together. allOf is going to combine n things together, but it's somewhat similar. But as we're going to see, the allOf method is more complicated to use than the completion stage methods for various reasons we'll talk about in the next part of this lesson. So that's the end of the overview of arbitrary-arity methods. And again, as you'll see, they're very tricky to program, and as a consequence, we're going to encapsulate them in a wrapper to make them more tractable.